Hi everyone, my name is Daesha McAdams and I'm a sophomore biology major here at Oglethorpe. So I chose to do my long talk presentation today on replant disease in Prunus dulcis and the management of it. So I'll get into a little bit more about what replant disease is later, but Prunus dulcis is the scientific name for almond trees. However, replant disease doesn't just affect almond trees, it can affect pretty much any plant, but nuts and stone fruits are the most common plants that are affected. And regarding the management of it, so there are already currently a few treatments that are used for this disorder, and I'll get into those later. And then the experiment that I'm going to talk about also discusses the different treatments. So, the reason that I got into this subject for my presentation was it's kind of a story. So, I recently started drinking almond milk instead of dairy milk, which I'm pretty sure a lot of people have. It's pretty popular. And so I just did it because I think it tastes better. And I've also heard a lot of good things about it. And I think it's just better for you overall. But I wanted to do some more research about what it is, how we get it, where it comes from. And as I was doing this research, I was coming across a lot of articles saying how almond production in the United States is suffering greatly recently. And I wanted to figure out why that was. And a lot of the articles were saying that it was caused by something called replant disease in commercial farming. And I had never heard of replant disease, as I'm sure most of you haven't. And so I was kind of curious, and I thought that that would be a good topic for my discussion. Another reason why I chose it was because plant pathology has always been really interesting to me. I think it's a really cool subject. And I wish that Oglethorpe had a class for it. I'm sure in the future that they could make that happen. But I think it's really important that agricultural problems are addressed fairly quickly and effectively because that's dealing with food and what we put in our bodies. And I think that we want to be assured that what we're eating and drinking is safe and healthy for us. So that's how I got into that. Okay, so the outline. I'm going to go over some of the things that I'm going to talk about before we get into them. So, I'm going to give you guys a little bit of background about what replant disease is and tell you guys a little bit more about how it affects some of the symptoms. Then, I'm going to get into the relevance, why you should even care about what I'm talking about. I'll talk about the hypothesis and get into the experiment, what they did, and then we'll discuss the results. And then I will leave you with a take home message, kind of wrap up all of my points. Okay, so some background about replant disease. So, replant disease, or RD for short, refers to the lack of productivity in fields after they've been replanted multiple times with the same or a similar type of plant, fruit, nut, etc. So it's actually very common, especially in California, where there's a lot of commercial agriculture going on. And it's mainly caused by abiotic factors having to do with the soil. So, some factors that could cause replant disease. So, nutrient deficiencies and toxins in the soil, which can come from overuse of pesticides over time, because plants get a lot of their nutrients, almost all of their nutrients from the soil. So, it's really important that the soil, isn't depleted and that the nutrient source is still very rich. And then improper pH of the soil is also another cause of it. Is once again, using all of those pesticides over and over and over will increase the acidity of the soil. And for some plants, that's okay. They need an acidic environment, but for other plants, it's very detrimental to their growth. And then another way that it can be caused is through soil compaction, which is pretty much just when the soil has been replanted so many times that the particles of the soil have become packed down so close together that the roots and the bud of the plant can't break through the top of the soil and grow up and out like it's supposed to. So on the left, I've included some pictures of a healthy plant versus a plant affected by replant disease, specifically an almond tree. So on the left here, you can see this is a tall, healthy plant. It's got a lot of leaves on it, pretty tall. It's not fully grown, but it's on the way. It's looking like it's growing healthy. And then the bottom picture right here is a picture of the roots of the healthy plant. So as you can see, the roots are pretty big, pretty spaced out. They're kind of growing evenly around each other. And so the picture on the right is a picture of an almond tree that's been affected by replant disease. So as you can see, it's not really growing up tall. They're kind of withered. There's not as many leaves as the tree over here. And then the bottom picture is the roots from this affected plant. So I think the most noticeable difference between the roots is that these roots are very close together and very compacted. They're kind of all on top of each other as opposed to these. And so that is a result of what I mentioned when I was talking about the soil compaction. So the roots are so pressed together that they don't have enough room to grow like they should. So getting back onto some symptoms of replant disease. So I think the most common symptom is uneven growth. And you can see that here kind of with the roots. So it's not growing evenly because of the roots being completely on top of each other and not able to spread out. So one side of the plant might be taller than the other, or some branches might be longer than the other. And then stunted growth is also another factor, another symptom of replant disease. So this plant on the right here is clearly shorter than this plant on the left. So stunted development is also a big symptom for this. And then I think the most important symptom is just a decrease in the overall quality and quantity of the yield of the plant. So for commercial farming, you want to produce as much of the plant, as much of the crop as you can, and you want to produce the best of the crop. So if it's being affected by replant disease, you're not getting as many usable plants as you could if they were all healthy, because you have some plants that are looking like this, which are not available for sale. So it's really kind of putting a dampen on the profit that the commercial farmers are receiving, because they're not producing as much and they're not meeting the increasing demand. So I also wanted to give some stats on Prunus dulcis, which, like I said, is just the scientific name for an almond tree. I also included a picture down here at the bottom, which is what the almond flower looks like, and then the buds with the actual almonds on the ends. So Prunus dulcis is a tree that typically grows between 10 and 15 feet. So like I said, this tree on the left over here isn't fully grown, but it's definitely getting there. So that just tells you how tall they're supposed to be. And then you can see what replant disease does for their actual height. And almond trees also grow best in really hot climates where it's really dry, not a lot of rain, and not a lot of humidity. So most of the almonds that are produced in the United States come from California, and that fits perfectly with their environment that they thrive in. It's really dry there. It's really hot, short winters, long summers, sorry. And so that is the perfect environment for almond plants to grow in. So about the current methods, this is getting into the management that I talked about on the first slide. So the most common method that is used today in commercial farming to combat replant disease is methyl bromide fumigation. So fumigation is pretty much just injecting the soil or spraying the soil and saturating it completely with a chemical. And usually these chemicals are used to prevent pesticides and prevent other bugs and stuff from coming and eating the plant and stealing nutrients from the plant, which is exactly what methyl bromide does. So methyl bromide is a very toxic, colorless, odorless gas. It completely depletes the ozone layer. It is very bad for the atmosphere, and it is also extremely bad for humans. If it's inhaled on a regular basis, it can cause a lot of health problems like lung cancer, skin cancer, pretty much anything you think of. It's very bad. So it's definitely important that we find a different method that is not so toxic to the environment and not so toxic to humans. And methyl bromide is also a class 1 ozone depleting layer. So it's basically the worst of the worst. Can't get worse than a class 1. It is so bad for the earth, and so that is why there's been a push recently to find a different chemical to fumigate the field with. All right, so the relevance. Why should you care about replant disease at all? So first of all, I want to talk about the agricultural impact. So approximately 1 million of California's commercial farming land is dedicated strictly to almonds. So if you eat almonds, if you drink almond milk, anything that almonds are in, they're coming from California, most likely, almost 100% of the time. And so this amount of high production, since almonds are a growing industry, like I said, a lot of people are switching to almond milk. It's a growing industry, and this requires for the fields to be replanted about every 15 years, which in commercial farming, that is very quick. It's a quick turnaround, and having to replant the same fields that often is not good. And also, 1/3 of California's stone fruits and nuts are affected by replant disease. So 1/3 may not seem like a lot, but I mean, for commercial farmers, they want to produce as much as they can. So anything that's hindering their production and their profit is something that we want to get fixed quickly and efficiently. And also, like I said, at almond milk, almonds is a growing industry. There's a lot of cool uses for it. I think it's really important that problems in the agricultural industry get fixed very quickly, because we don't want to just keep drowning our crops in chemicals, because that's what we're putting in our body, and nobody wants that. So I think it's important to know that the land use for commercial agriculture in the US has almost quadrupled. So commercial agriculture is a really big part of the US. And so it's where a lot of our food comes from. That's not meat, or that's not, artificial. So I think it's really important that we find solutions for these problems, because we want our food to be safe for us. And then again, the environmental effects. So like I talked about with methyl bromide, not very good for the environment, not very good for humans. And if it's not safe for the environment or for humans, we probably don't want it in our food, in our crops, etc. So we need to find a more sustainable solution to treat the crops with, which is what the experiment that I'm going to talk about will get into. Oh, also, this is a picture of an almond tree and all of the flowers. It's really pretty. But anyway, getting into the experiment. So this experiment was conducted by 3 scientists, G.T. Brown, J.H. Connell, and S.H. Snyder, and they all work for the Department of Plant Pathology at the University of California, Davis. So this study was published in APS Publications, which stands for American Phytopathology Society Publications, sorry. And it was published in 2007. And so the goal for this experiment was to just find a more effective treatment for replant disease other than methyl bromide. And then on the side here, I've included, you can't really see the top one, I'm sorry, but I've included the molecular formulas of the chemicals that they're going to use in the experiment. So the top one is methyl bromide. There's just another hydrogen bond up at the top. The second one is called chloropicrin, and that is another substance that they use. And then this bottom one is called 1,3-D for short, but the full name is 1,3-dichloropropene. Okay, so the hypothesis for their study was that alternative fumigants to methyl bromide will prevent the effects of replant disease. So let's get into the materials and the methods. So there were actually 2 different trials done. Well, there were more than 2, but there were 2 different areas that the trials were conducted. So first I'm going to talk about the orchard trials, and then I will get into the microplot trials. So there were 3 different orchards that they wanted to observe, and they observed these orchards over a 5-year period. So since soil is has such a big impact on replant disease and on the plant itself, they wanted to test out 2 different soils to see if that would have an impact on the effects. So the first soil that they used was a Nord loam soil, which is kind of coarse, grainy, a mixed soil, and it has a pH of about 7.4. And then They planted that in the first two orchards. And then in the third orchard, they used a Farwell loam soil, which is more fine, and it has a pH of 7.2 to 7.4, so kind of similar pHs. So they did use different types of fumigation for each of the trials. So the first type of fumigation they used was called broadcast fumigation, which means that you're just saturating the entire area with the chemical, as opposed to injecting it like they do in the microplot trials. So the orchard trials were located right outside of Chino, California, but the microplot trials were kind of in a more controlled environment. They were actually grown in an agricultural center in San Joaquin Valley. So the microplot trials, each plant had their own individual kind of plot, and then had their own soil, own roots, watered separately, everything. And so these microplots were monitored over a 4-year period, and they did only use one type of soil, which is called Hanford fine soil, which is kind of a sandy, fine soil. And then for the fumigation in the microplot trials, as opposed to the broadcast fumigation, they used individual, like injected fumigation. So they injected it about 10, 15 centimeters down into the soil of each plot. Okay, so this is the first result I wanted to go over, and this is the result of the first orchard in the first orchard trial. So you can see the fumigants they used here on the left. So obviously there was a control with no fumigants applied. MB stands for the methyl bromide. CP stands for chloropicrin, the second molecular formula that I showed you. And then 1,3-D is the 1,3-dichloropropene. And so the way that they rated tree performance in the first growing season was by tree height, by trunk diameter, and then also by disease rating. So disease rating is basically they came up with a scale of 0 to 5, 0 meaning that the plant is completely healthy, no disease, could definitely be used in the commercial marketing. 5 being the plant is completely diseased, almost dead, definitely cannot be used or sold on the market. So I wanted to point out that CP kind of dominated in pretty much every category. So we have the highest tree height, the largest trunk diameter, and then also the lowest disease rating. Okay, so the second chart, I know this looks like a lot of data. I'm going to try and simplify it for you, hopefully. So these are the results from a couple of the microplot trials. So I wanted to focus on this last one down here. So they basically did the same thing as the orchard trials, except they used different amounts, different kilogram amounts of the fumigant. So right here we have MB again, CP, IM, which is iomethadane, which is just another fumigant that they wanted to try out. And then again, they measured tree growth by height, diameter, trunk diameter, and then disease rating again. So I've circled the results for CP in height and also in disease rating. Once again, they have the highest numbers, 2 in height, and then the lowest disease ratings. And then also down here, when they coupled chloropicrin with iomethadane, they also still had some of the higher results. So I wanted to point that out. And then this is the last results chart that I have, and this focuses specifically on chloropicrin. So this A chart is focusing on the increase in trunk diameter, and then the B chart is actually focusing on marketable yield. So this is just the amount of plants that are viable to sell on the market. And one thing that I thought was really interesting about the B chart was that the rate of chloropicrin, once it hit about 0.1 kilograms, it kind of steadied out or stayed the same. So I think that's really good for farmers because that means that you don't have to use or buy a whole bunch of chemicals to treat your fields with because it works just as well at 1 kilogram as it does at 0.1 kilogram. So I thought that was really good because the less chemicals we can use, the better, and the better for our pockets. So my conclusion or take home message, I want you guys to remember that replant disease has detrimental impacts to the agricultural industry, and also detrimental impacts on our health because we're consuming the agriculture. And then the other thing was that chloropicrin is an effective and more environmentally sound alternative to MB. You don't have to use as much of it. It's better for the soil, better for the environment, better for the plant all around, and better for us. So thank you guys for watching my presentation. I hope you learned something. I hope you liked it. And yeah, bye.